Before we exploit anything or try to scan anything, we have to understand what services are actually running on a target. And that's where service interaction comes in. Service interaction means directly communicating with network services to gather real technical information. So instead of just guessing what's running, we actually talk to the service and see how it responds. We can think of it as a port scan. A port scan that tells you a door exists, and then service interaction tells you what's behind the door. So with service interaction, we talk directly to those doors to see what service is running, what version it is, how it responds, and how secure or insecure it looks. This helps to understand what could be attacked and how it could be attacked. So for this app, the first thing I'm going to do is to run the help command. So the help command gives me the tools and targets that are available in this lab. This lab is about basic connectivity. That means, can I reach a service? Is the port open? What service is running there? And what does the service say when I connect? We can think of it like knocking on doors in a building. So the IP addresses are the building, the ports are the specific doors, and the service is who answers the door. Now, a port is a numbered communication endpoint on a computer. So different services use different ports. As we can see here, FTP uses the port 21. We have SSH using 22, telnet using 23, HTTP using 80, and so on and so forth. Now, the objective for this lab says connect to at least one service using netcat and one using telnet. Netcat is a networking tool that allows us to connect to ports, read service banners, and to test connectivity. And telnet is an older protocol that communicates in plain text. And a banner is the message a service sends when you connect. So it usually shows the service name and the version. Now, the ports we see here are open ports. An open port only means that a service is listening. It doesn't mean that the service is vulnerable so it can be exploited. Now, if we pay attention to our hint in this lab, it says try two commands. So I'm going to try the first command. So with this command, I'm using netcat to connect to the port 21, which is the FTP service, as we can see here. We're using netcat to connect to the port 21, which is the FTP service. The -v flag simply means verbose, so netcat will tell us what is happening. Now when I press enter, we see that the connection succeeded, and then we receive a banner. This banner tells us that FTP is running. The software is this VS-FTPD, and the version is 2.3.4. I'm going to run the second command in the hint, which says telnet 192.168.56.103 on the port 23. And when I press enter, we get a welcome message. Welcome to telnet server. So this tells us that the port is open and telnet is running, and communication is also happening in plain text. Now I'm going to try to run the first. I'm going to try to use the first IP address without the verbose output. So this is the first IP address, and this is the format without verbose output. And I'm going to try to use this IP address with this command. So, and see. IP, sorry, NC 192.168.101 and the port 21. This is the command we typed, and from the result, we still receive the same banner message where that tells us that FTP is running and the software is VS-FTPD, and it tells us the exact version. So in this lab, we use netcat and telnet to test connectivity, basic connectivity. And we also use it to connect to common services and observe how different ports respond. This lab is about banner grabbing. So banner grabbing is connecting to a network service and reading the information it sends back, which is called a banner. A banner normally tells us what service is running, the software name, the software version, and sometimes even the operating system. And this is important because vulnerabilities are version specific. So the objective for this lab is to successfully grab banners from at least 3 different services to identify their versions. And we are given hints on commands that we can use. For this video, I am going to be running the 3 hint commands. But first, I'm going to type help. Help shows us the available commands, the banner grabbing techniques, and then it shows us target IPs and ports. So for this lab, we'll be using 2 tools, netcat, which is a networking utility, and telnet, which is a text-based protocol that is used for reading service responses. The first command I'm going to run is nc-v 192.168.56.201, which is the first command in the hint, and then the port 22. So 192.168.56.201 with the port 22. So with this command, we are connecting to port 22, which is the default port for SSH, using netcat in verbose mode. So from the result, we get a banner, and the banner tells us a lot. The banner tells us the service is SSH or Secure Shell, and it tells us that the software used is OpenSSH, and the version is 7.9, and that it's running on Debian 10. The next command I'm going to run is telnet 192.168.56.206 and the port number 5432, which is the second command given another hint, the Postgres banner. So this command connects to the port 5432, which is Postgres SQL's default port, using telnet. Now the result confirms that Postgres SQL database server is running and is reachable. Some database services don't show detailed version information by default, but this response tells us that the service exists and it's exposed. The next command I'm going to be running is this command, which is nc-w3 192.168.56.202 and the port 21. So this command connects to port 21, which is the FTP service, using netcat with a 3-second timeout. The -w3 option means wait 3 seconds and then quit. This is just to make sure the connection doesn't hang while it's waiting for input. So when I press enter, we see the banner which tells us the service is FTP and it tells us that the software version is VSFTPD and the version is 2.3.4. And in all cases, we see that the service sends its banner and then closes the connection. That is why we get this result, connection closed by foreign host over here. We also got the same thing when we run the second command and the same thing when we run the first command. So in this lab, we practiced banner grabbing using netcat and telnet to show or identify the running services and software versions. In this lab, we are learning how to get web pages from the command line using curl and wget. Curl is used to send requests and view responses, and wget is used to download content from web servers. These tools allow us to interact directly with web servers and APIs without using a web browser. Whenever you visit a website, your browser sends an HTTP request to a server, and the server sends back an HTTP response. Curl and wget let us do the same thing, but we do that from the terminal. So the goal of this lab is very simple, is to use either curl or wget to fetch the contents of the domain example.com. The first thing I will do is to run the help command to see the available tools that I can use in this lab. The next command I'm going to use is curl https example.com. Now this command, we are using curl to send an HTTP GET request to example.com. Now from the results, we see that curl got the server's response and printed it back to the terminal. And what we are seeing here is the raw HTML of the web page, which is exactly what the web server is supposed to send back. The next command I'm going to run, wget https example.com. Now, unlike curl, wget downloads the content and saves it to a file. So first thing wget does is to resolve the domain name to an IP address. And then it connects to the server over HTTPS port 443. And then the server responds with 200 OK, which means that the request was successful. And then finally, the page is saved locally in index.html or as index.html, and the download is complete. Both tools fetch web content, but they're used differently. Curl is best for viewing and testing responses, and wget is best for downloading and saving files. So in this lab, we use curl and wget to send HTTP requests, to retrieve web content, and to understand how servers respond without using a browser. So in this lab, we are learning how to inspect HTTP headers and analyze server responses using curl and wget. So instead of downloading a web page, we are focusing on the metadata that the server sends before the content. Now, HTTP headers are pieces of information sent by a server that describe its response. They tell us things like whether the request was successful, what type of content is being sent, and how large the response is, and sometimes what server software is being used. So the goal of this lab is to view and analyze HTTP headers for example.com using either curl or wget. The first thing I'll do is to run the help command to see the available tools and commands for this lab. The next command I'm going to run is curl -i https example.com. So here I'm using curl with the option -i. The -I flag tells curl to fetch only the HTTP headers and not the web content. So from the results, we see this line which tells us that the server is using HTTP version 1.1 and the request was successful. 200 OK status means that the page was found and returned correctly. This line tells us that the response is an HTML document which has been encoded using UTF-8. This is the size of the response body. This line shows information about the server that is handling the request. This is the time that the server generated the response. The next command I'm going to run, wget -server -response https example.com. Now this command tells wget to display the HTTP headers while still downloading the page. From the results, we see that wget is resolving the domain name to the IP address, and then it connected to the server over the port 443. We see here that the connection request was successful. We basically see the same results as when we use the first command, the curl command. But the only difference is that it saves to index.html, as we can see here. So the difference is that curl with the -I flag is best for quickly inspecting headers, and wget with the server response in the command lets us see headers and download the content at the same time. Now this lab is important because HTTP headers usually show valuable information about server configuration and behavior. In this lab, we are learning how SSL and TLS certificate validation works and how to handle certificate errors using curl and wget. We'll see how to access a website that uses a self-signed certificate, which normally causes HTTPS connections to fail. So what is an SSL or TLS certificate? SSL stands for Secure Sockets Layer. It was the original protocol that was created to secure communication over the internet. Its job was to encrypt data between a client and a server and to protect information like passwords and credit card details. TLS stands for Transport Layer Security. It is the modern and secure replacement for SSL. It does the same job as SSL, but better and safer. When you connect to an HTTPS website, your browser or client checks the server's TLS certificate to make sure it's trusted and issued by a valid certificate authority. If the certificate can't be verified, the connection is blocked to protect you from attacks. This lab is showing us how to bypass the same security check that browsers use when they warn us that a website is insecure, so we can safely test and understand certificate problems. Now, what is a self-signed certificate? A self-signed certificate is not issued by a trusted certificate authority. Because of that, browsers and command line tools don't trust it by default and will usually block the connection. The goal of this lab is to fetch the content of self-signed badssl.com, even though the site uses an invalid certificate. And to do that, we'll intentionally bypass certificate verification for testing purposes. So why are we fetching content from a site with an invalid certificate? We are not doing it because it's normal or safe, but to learn and test specific security scenarios. An invalid certificate doesn't mean that the server is unreachable. It just means it's untrusted. So the lab is teaching us the difference between encryption and trust. HTTPS gives us two things. First, encryption, which protects data in transit, and authentication, which confirms we are talking to the right server. A self-signed or an invalid certificate breaks trust, but it doesn't necessarily break encryption. So this should usually be done in a lab or testing environment. If you disable certificate checks, it removes protection against man-in-the-middle attacks and should never be used in production. The first thing I'm going to do is to type help to see the available commands. I'm going to use the first command, curl-k https self-signed.badssl.com. Here I'm using curl with the K option. The K flag stands for insecure and it tells curl to skip SSL certificate verification. Now, because certificate verification is disabled, the HTTPS connection succeeded and the server sends back the web page content. So what we are seeing here is the raw HTML of the page, which confirms that the only issue was certificate trust, not connectivity. The next command I will use is wget. Okay, so let me be sure. I just verified the command wget -no -check certificate TPS self -signed. This should be signed, not assigned. .badssl.com. So with this command, I'll be using wget with the no check certification option. It does the same thing as the curl command k flag, but wget downloads the page instead of printing it. So if we look at the results, the first thing it does is to resolve the domain name, and then it connects to the server over HTTPS on the port 443. It also displays a warning here saying that it cannot verify the certificate, which is an expected warning because it tells us that the certificate is not trusted, but the connection continues because we allowed it. Then it responds with an OK message, meaning that the request was successful, and then the page is saved locally as index.html. So with these two commands, the first command, curl with K, is useful when you want to quickly check the content or test an endpoint, and wget with the no check certificate is useful when you want to download files from a server with certificate issues. So in this lab, we learned how to bypass SSL and TLS certificate verification using curl and wget to access a site with a self-signed certificate. So in this lab, we are learning advanced curl techniques, meaning we're using a few extra options to control how our web requests behave. Curl is a command line tool that is used to send requests to web servers. Whenever you open a website in a browser, your browser sends a request. Curl lets us do the same thing, but from the terminal. Before we run the commands, there are a few key terms we should look at. The first term is an HTTP request. An HTTP request is a message your computer sends to a server asking for something, like a web page. An HTTP response is what the server sends back, which includes a status code and content. A redirect means the server tells the client to go to a different URL. Headers are extra pieces of information sent with requests and responses. And user agent tells the server what type of client is making the requests. The first command I'm going to type is help to see the available commands. The next command is the first command here. So I'm going to highlight this and copy, then paste. Now with this command, the -l option means follow redirects. So if a server responds with go somewhere else, curl will automatically follow that path. Looking at the results, the server redirected us and curl followed the redirect to the final page. And we can see here that the response is in a JSON format. So here we have headers. These are the headers that curl sends to the server. Accept means I can accept any type of response. Host shows which domain we are talking to. And user agent shows that the client is curl. This is the IP address that the server sees as the requester. And in real life, that would be your public IP. And this URL confirms the final URL. So even though in the command, as we can see here, we requested for this, we ended up at this, at get. So curl followed the redirect and reached the final destination successfully. The next command I'll be using is the second command I got after I typed help. So I'll highlight and paste it. Now this time we are using two options, -I and -l. -I flag tells curl to show the HTTP response headers, and L still shows or still follows redirects. When we press enter, in the first part of our results, we see 302, which means redirect. So that tells us that what we are looking for temporarily lives somewhere else. This tells the client where to go next. Server is the backend server software. And over here, we see that the request worked successfully because we see 200 OK over here. And the response body is in JSON format as well. Now the next command is going to be the third command here. So this command sends data to a server that is similar to submitting a form on a website. So what we are going to be submitting is this. When I press enter, we see the most important part, which is this. This confirms that the server received exactly what we sent, which is name equals test. You also see our headers. And this shows the data format that is used by HTML forms and the size of the data sent. Again, I'll type help. I'm going to copy this command and paste this here. So this command changes the user agent. Normally, curl identifies itself automatically. Here, we are telling the server that our client's name is my agent, and the domain we are using is example.com. Earlier on, I mentioned that user agent tells the server what type of client is making the request. Now, when I press enter, we receive the HTML source code of the page. Now, why does it look the same? Example.com doesn't care about the user agent. It just serves the same page to everyone. The user agent identifies the client, and changing it can affect how servers respond. So a quick recap of what we used. We used the -L flag in our commands to follow redirects. We use -I to show HTTP headers. -D sends data. We use -X for post to submit data, and we use -A to set the user agent. So in this lab, we used curl to follow redirects, to inspect headers, send data, and customize requests.